So this is my lovely grade 12 group. It's been a long time coming. Yeah, guys, it's been rough. It's rough on the TikTok streets. It seems like not everybody is happy about me being here and doing the things that I'm trying to do. So it's very hard. It's very late on these streets. Yeah, but we are not complaining. We are not crying. We are happy to be back in winning ways. Hopefully, you guys have been good and you are pushing the syllabus at a very accelerated and high pace. Yeah. Uh, there's no other group in the country right now that needs to be as self-sufficient as the grade 12 2025 cohort group. Um, we will more. Very good. Grade 9. So tomorrow, grade 9 will be having a session for grade 9 tomorrow at 7 a.m. Grade 9, I'll see you at 7 a.m. Grade 10, I will see you at 8 a.m. or in actual fact at 8:30, because nowadays the sessions are going on a bit longer. Why? Because some people, they ask critical questions in the comment section, and sometimes those need to be addressed not just casually but thoroughly. So I give myself the chance, and I give people a chance to then be able to have things explained. And I think it's good as well when they listen in the YouTube video, when they re-listen again for them. So it's all okay. We started out with quadratic number patterns, grade 12. We did quadratic number patterns. Okay, and I really appreciated those who were able to send me their work of the work that I had given last time. And I love it. I really love it. Proactive learners are the best learners in the world. Proactive. This word proactive. There's a book that I really love and I like promoting when I am in the presence of learners. It's a book by a guy called Sean Carvey. It's called The 7 Habits of Highly Effective Teenagers. And one of the habits there talks about the first habit says you need to be proactive. Being proactive means being a self-starter. Someone that does things without being told to do them. Someone that does things because they know the importance of doing them. And they make sure that whenever the occasion allows them, they do what needs to be done, whether they feel like doing it or not. That is someone who is proactive. They take initiative, and obviously that must be informed by being driven by something that they have probably set for themselves. There's that drive, something that drives them, that is born from an ideal that they have. So please, guys, be proactive. The book is called The 7 Habits of Highly Effective Teenagers. Teenagers that are highly effective have these 7 habits that Sean Carvey speaks about. Nowadays you can actually even get the contents of a book without even reading it. You can go to an AI engine and just type in The 7 Habits of Highly Effective Teenagers. Can you please summarize this book for me and what it teaches, and as a grade 12 learner who is doing matric, what lessons can I draw from that particular book? And then AI engine will just give you the 7 habits and then incorporate the things that you need to learn as a grade 12 learner from that book. So it's beautiful, man. And please, guys, use these resources that are at your disposal. You guys are in the midst of a amazing revolution where there's information at your disposal, at your fingertips. You can learn anything, absolutely anything, if you want. So don't mind the fact that I'm this teacher who has decided to have a TikTok platform where I do classes. That's just me, but you can learn these things without even me. That's what's beautiful about today's influx of information. Okay, Alright guys, we did, like I said, quadratic sequence. We have put that behind us. Today we are going to look at arithmetic sequence. This is grade 12, people. And I know that some of you are already way far into the syllabus with your grade 12 content, and I'm happy for you. Please, people, I'm happy for you. If you are here because you just want to sort of like check and close the gaps and check if you are fine and you are good, welcome. If you are here for the first time and you are wanting to just get onto that boat of being consistent with your grade 12 maths preparation, then you are in the right place. Because at least the community of learners that is growing there, that are collaboratively in a group, who can assist each other when there's a need. You can get to know people that you've never known before from various parts and corners of the country, and you guys can interact and collaborate. Collaboration is one of the key 21st century skills that learners need to have nowadays and age. You will thrive in life if you can collaborate with others. I am also at the verge of thinking of other methods and means and ways to probably extend what I'm doing, not just limit it to this platform. And I'm looking to collaborate with other people, so that I can actually do something maybe even more than what I think here. So it's very important, these things: collaboration, working together, sharing of ideas and expertise. So please guys, be a bit proactive in the group. Talk to each other, check if you can assist each other, check which grades and subjects you guys are doing. Be proactive, guys. It's very important to be proactive. You must be proactive. If you are proactive, you'll win. So let's look at this. We're going to look at sequence and series. We're going to look at number patterns, but specifically today we are looking at arithmetic sequence. Arithmetic. What is a number pattern? A number pattern is also called a sequence. What is a sequence? It's a list of numbers that have a particular order and they are written consecutively, meaning one follows the other number. All right? That is a sequence. It's a list of ordered numbers. Very key. Arithmetic sequence. A sequence. What is an arithmetic sequence? An arithmetic sequence is a sequence where the difference between the consecutive terms remains constant. A sequence where the difference, and I just want to add, where the first difference between the consecutive means one term after the other. It's just one term following another. That's what the word consecutive, one after the other. That's what the word consecutive means. Between the consecutive terms, it's where the first difference between the consecutive terms remains constant. So we say the following: D. This D stands for constant difference. D is equal to T2. What does T2 stand for? T2 means term 2. Okay, please people, not the term that you're talking about at school, like term 1, term 2, term 3. No. I'm talking about the value, the particular value, the position that a particular value holds in a sequence. So the position of a particular value, term 2 minus term 1, the term that occupies the second position, the term that occupies the first position, it's equal to term 3 minus term 2 consecutive terms, the later minus the former. Term 4 minus term 3. Obviously, the difference between these terms should be a consistent or constant one. We denote the constant difference with the letter D, small letter D. All right. Now, the letter A in a arithmetic sequence stands for the first term. In other words, term 1. So A stands for first term. D, like I said, stands for constant difference. So in an arithmetic sequence, we have A, the variable A, which stands for first term. That means term 1. And then D, which stands for the constant difference. In other words, we can say term 2 minus term 1. It should give us the same value as term 3 minus term 2, and so it goes. We can say term 4 minus term 3. We can say term 5 minus term 4, and you get the point, guys. All right? Now, consider the sequence. Let's look at the sequence, guys. 2, 5, 8, 11, and 14. Then this ... indicates that there's an infinite number of values that we can list, but we will not have the space to list all of them. So, two things. We see here that what is the value of A in this sequence? What's the first term in the sequence? It is 2, because 2 is the first term. Then secondly, what is the constant difference, the value of D? T2 minus T1. In other words, term 2, which is 5 minus 2, what's 5 minus 2? It's 3. We should consistently get the same number if we say term 3 minus term 2. What's 8 minus 5? It's 3. We should get the same difference if we say term 4 minus term 11 minus 8. It's also 3. So this is definitely a arithmetic sequence. Okay. We've confirmed it. Now, here's something that we can actually also say by extension. Term 1 is equal to 2, right, from the sequence, which is the value of A. So in terms of A, the first term is A. Term 2, which is the value 5, is actually equal to 2, which is A, plus 3, which is the constant difference. So term 2 is 2 plus 3. So generally we can say it's A plus D. A being the first term, D being the constant difference. It is term 2. A plus D, generally speaking. Just like term 1 is A, generally speaking. Term 3, in terms of A and D. Term 3 we know is the value 8. What is term 3? It's 2, meaning A, plus 2 times the what? The constant difference. 2, which is A, plus 2 times 3. This 2 times the 3, obviously that's 2 times D. 2 times the constant difference, plus 2 gives us the third term. What about term 4? It is 11. It is also 2, which is A, plus 3 times this time round. 3 times what? The constant difference. So it's A plus 3D generally. And then I'm sure term 5, you guys get the drill. Term 5 will be A plus 3D. Term 4 will be A plus 3D. Term 5 will be A plus 4D. And I'm sure you can understand what will term 6 be. Just for argument's sake. Generally speaking, so term 1 is A, term 2 is A plus D, term 3 is A plus 2D, term 4 is A plus 3D, term 5 is A plus 4D. What will be term 6 in terms of A and D? Term 6 in terms of A and D. Term 6, T6, in terms of A and D will be equal to, I'm waiting for someone in the comment section to give me a thumbs up. Term 6 is equal to, drum roll, Swazi, at number 1 with A plus 5D. What does everybody else say? Ontatile has tattered me as well. Eye patch with the eye patch. A plus 5D. Ugana M Wana says 5D. Norma says A plus 5D. Okay, I think we've got a winner there. Okay, on Swazi was spot on, and everybody else that said A plus 5D is 100% spot on. So for our general expression of term 6 in terms of A and D, A plus 5D is the expression. Very important. Okay, this is just something to note, guys, please. So generally speaking, if we look at our arithmetic sequence, the general term we can use to denote an arithmetic sequence is Tn is equal to a plus, and this is important, in brackets, n minus 1, close brackets, times d, brackets, then d. This d is multiplied to the binomial n minus 1. Okay, very important. This is a plus n minus 1 times d. Very critical. Okay, let's go on. This formula can be used to what? To determine the value of any specific term of a arithmetic sequence. I repeat, this formula above can be used to determine the value of any specific term of a arithmetic sequence. This AS just stands for arithmetic sequence. That's just my short for arithmetic sequence. Okay. A plus d into n minus 1. It looks n better, sir. Very true. Okay, that's why you will actually see in my examples that I've actually incorporated that notation exactly. Spot on, Ghana M1. Example 1. Look at this arithmetic sequence 4, 9, 14. 3 terms, which is enough to basically conclude about the type of sequence this is if we have 3 terms. Determine the general term of the sequence. A for this particular sequence is what? Is 4. Remember, A stands for the first term. D is equal to term 2 minus term 1, supported and confirmed by term 3 minus term 2. So what's 9 minus 4? It's 5. What's 14 minus 9? It's also 5. So therefore we have confirmed that the particular constant difference is 5. NM Falang, I think you were actually here in the previous session, right? And if I think I don't know if you actually here with the right kind of heart, but like yeah, you do kind of give me vibes of you tend to play, you are here seriously, but at the same time, so if really the live is boring you and so forth, I do encourage you to sort of like look for other content so that you can be okay, right? Yeah. Tn is equal to, now A, guys, all right, we can go ahead, since we have the value of A, remember Tn is equal to A plus n minus 1 d, it is the general term. And then just like Ganawana said, okay, Tn is equal to A, I also tend to want to write the coefficient or the monomial of d outside the bracket before n minus 1 instead of on the other side. Why? Because sometimes learners, they forget to actually take this and distribute it inside this bracket. Okay, even though we know that multiplication, n minus 1 times d into n minus 1, multiplication is commutative. The order doesn't really matter. But it's amazing what learners sometimes do, under pressure. So let's avoid that. Okay. So if we substitute into the formula, okay, we have Tn is equal to 4. A is 4 plus, then the d we write before the binomial bracket. So the d obviously is equal to, we got 5, right? 5 into n minus 1. So we distribute the 5 inside the bracket. 5 times n is 5n. 5 times negative 1 is negative 5. And then it's a matter of adding the like terms. 4 minus 5 is negative 1. So we write the 5n minus 1. This is the general term of 4, 9, 14. So it's always advisable to first find the value of A and the constant difference. Then we can substitute the value of A and D in the form that best suits our expression, okay? And then we can go ahead and distribute the 5 into the n, 5 into the negative 1, we get Tn is equal to 5n minus 1. Okay. Yeah. So Kele, I'll be streaming at 10:30. All right, for grade 12. Yeah. I'm actually decided to actually do that for grade 12, stream in the evening rather than stream during the day or something like that. Okay. Yeah. And yes, thank you so much, Ontatil. I am working according to the ATP. I'm working from the beginning. So I've actually done quadratic sequence as an introduction for the first 2 sessions. I've uploaded the sessions that I did onto the YouTube channel, which is also called Maths is a Game. So it's there, part 1 and part 2. Now we are actually continuing on with arithmetic sequence, and we'll continue in that order, guys, according to the ATP, covering the depth and the scope of the work according to what we've been given. Yeah, so that's why. Thank you so much, Ontatile, for explaining that. Unati was asking, sir, is D and N the same? No, D and N is not the same. Remember, N denotes position of a particular sequence, all right? N simply stands for the position, whilst D is the constant difference. So those things are not the same thing. All right? They are not the same thing. Then the next question was saying, calculate the value of the 50th term. Remember, guys, we had gotten the general term Tn is equal to 5n minus 1. Okay? Swazi, it is, like I said, 10:30 p.m. Not a.m., p.m. So I do it at night for you guys. Yes, I'll be holding classes during school time, but not during school, right? But during that term time. Can you just hold on a second? I just need to. Okay, sorry, I just had to quiet down these guys. Okay, grade 9 I'll be doing at 7 a.m. in the morning. Grade 10 I'll be doing at 8 a.m. in the morning tomorrow. So grade 9, 7 a.m. Grade 10, let's say grade 10 8:30, because grade 9 I'll do at 7, and then grade 10 8:30. Okay, grade 9, 7 a.m. Grade 10 8:30 tomorrow. All right, that's kind of like the sequence of things as we will do them just before schools open. All right, so standard, we'll keep it like that. Grade 11 at 9 p.m. Okay, grade 11 9 p.m. Grade 12 10:30, and then, like I said, grade 9 in the morning at 7 a.m. and then grade 10 at 8:30 a.m. All right. So grade 9 and 10 are in the morning, and then grade 11 and 12, they are in the evening. All right, let me just continue here. So now we wanted to get the 50th term, guys. So we go to that general term, Tn is equal to 5n minus 1. And please understand, they want the 50th term, meaning the term that occupies the 50th position. And position means we substitute 50 in the place of n, which is very important. So that Tn is equal to 5n minus 1. I substitute what? 50 in the place of n. When I substitute, I use brackets, please, guys. 5 times 50 gives you 250, minus 1 gives you 249. So term 50 is equal to 249. That's simply how we get the 50th term. Okay. All right, so that's just 2 things. Remember, we had said the formula can be used to determine the value of any specific term of an arithmetic sequence. So we've just looked at that. found the general term first, and then found a specific value of a term in that sequence, the 50th term to be exact, and we got 249, okay, from Tn is equal to 5n minus 1 by substituting 50 in the place of n and multiplying out and getting 249. That's term 50. This is grade 12. Example 2. Calculate the value of term 36 in this arithmetic sequence. So we have another arithmetic sequence. Please take note of this arithmetic sequence. We have a positive, a negative, and a negative number. Okay, so let's look at it. We are told it's arithmetic, which means it must have a first term and a constant difference. I mean, if they tell us it's arithmetic sequence, then it must have those things. So term 1, a is equal to 1. What is the constant difference? The constant difference is term 2 minus term 1. We can confirm it by also looking at term 3 minus term 2. So what's term 2 minus term 1? In other words, it's negative 2 minus what? Positive 1. So that's like negative 2 minus 1. Okay, negative 2 minus 1 is actually equal to negative 3. Let's confirm with term 3 minus term 2. We have minus negative 5 minus 2. Please take note, people. This is negative 5. The instruction says we subtract the previous term. So we subtract, what is the previous term? It's minus 2. So that's like saying minus 5 plus 2, which we know is negative 3. Okay, are you with me? So it's still negative 3, and that is confirmed. All right, so we know our constant difference definitely is negative 3. Guys, we don't necessarily have to confirm it, but I'm just saying, all right, it's just something I'm doing so that we can just see how it is that really an arithmetic sequence has a constant difference for the same type throughout. Okay, so a is equal to 1, d is equal to negative 3. Then we go and write down our general formula. Tn is equal to a plus n minus 1d. And remember, it's better to write it Tn is equal to a plus d to the power n minus 1, so that we can see that the d is distributed. So let's do it. Tn is equal to 1 plus. Now the d is negative. So it's negative 3. And then we put that in brackets, into n minus 1, which is also in brackets. What does that mean? Distribute the sign that we get. Now the positive times the negative gives us a negative, and then negative 3 times n gives us negative 3n. The positive times the negative, like I said, gives us a negative. Negative 3 times n gives us negative 3n. Negative 3 times negative 1, negative times a negative gives us a positive. Then 3 times 1 gives us positive 3. Are we together? Then we conclude. How do you simplify? We add and subtract the like terms. First term is negative 3n. The constant terms 1 plus 3 gives us a positive 4. So therefore we have Tn is equal to negative 3n plus 4. This is our general term. But the question didn't want the general term. We wanted the value of T36. So when we have the general term, we can then substitute the position. In other words, the 36 in the place of n. So that means minus 3 times in the place of n, we substitute 36 plus 4. Then we use our calculator. Negative 3 times 36 gives us negative 108. Plus 4 gives us negative 104. And guys, you can confirm this as I go along, just to verify and check and make sure that indeed term 36 is equal to negative 104. Okay, so very importantly, when they want the value of T36, if we don't have the general term, we need to first find it. But in order to find it, we need our A and our D. We can then substitute. We can then distribute the negative 3 inside the binomial term, add and subtract the like terms, and get the general term, which is negative 3n plus 4. Then, because we wanted term 36, we use that general term. We substitute 36 in the place of n, and then we get term 36 is equal to negative 104. This is grade 12, Kumo, grade 12. Sequence and series. Kanya, you just missed grade 11. We had it. We started with equations and inequalities, quadratic equations today. Specifically, we did maximum and minimum, how to find the maximum and minimum of a quadratic expression. I'll be uploading the video onto the YouTube channel, which is Maths is a Game. You can check it out on my YouTube channel. On my bio. On my bio on Maths is a Game. Check out the bio, go on there, subscribe, and then you can watch the previous videos that we've done, because I upload all the live sessions that I do here. I upload them onto the YouTube channel so that people can watch them at their own time, their own pace, under their own circumstances. Okay. TK, I will not conform to what you are asking me to do because I am following a particular program. So at the moment we are doing arithmetic sequence. If you want to still be here, you can wait for then, or you can please divert to a appropriate channel where you can get geometric sequences, or wait for the appropriate time when I do get there. Okay, next. To determine, this is the next thing we're looking at now. To determine the position of a term. Okay, remember, position of a term means the value of n. To determine the position of a term, in other words, which term, we equate Tn to the given specific term value. Okay, and then what do? We solve for n. Okay, I repeat again. To determine the position, in other words, n, of a term. So sometimes they'll ask which term is. We equate Tn, the general term, to the given term value. And then what do we do after that? We solve for n. So let's look at an example. The question here says, which term in the arithmetic sequence 1, 9, 17 is equal to 193? Please take note of the question and how it has been phrased, people. This question is saying, which term in the arithmetic sequence 1, 9, 17 is equal to 193? This means there's actually a specific term. As we go along in this sequence, there's a specific term that has the value of 193. What we are asking for here, what position does this term occupy in the sequence? What position does this term occupy in the sequence? In other words, what's the value of n for this specific value of the term? So what we do, from what we've learned above, is that to determine the position of a term, in other words, which term, we equate Tn. In other words, we take Tn and we say equal. We equate it to the given specific value of the term, and then we solve for n. So what did we ask? Which term in this arithmetic sequence is equal to 193? So what we do is we say Tn is equal to 193. So step number one, equate Tn with that specific value of the term. Step 2, we go ahead. What is Tn? Tn is a plus n minus 1 d, which is equal to 193. Now you know that most of the day I will write it before the n minus 1, as you see me that I have done so here. So obviously before I even do that, I want to know what is my a value. My a value is 1, so that I have that to be written down. And then d, what is d? D is term 2 minus term 1, which can be confirmed with term 3 minus term 2. What's 9 minus 1? It's 8. Okay, so a is equal to 1. In the place of a, I've written 1. Plus, remember the d, I write it before the binomial so that I can know that I have to distribute it after I am done. Okay, so we do this. Take the 8, we distribute to the n. We take the 8, we distribute it to the negative 1. Okay, then 8 times n is 8n. 8 times negative 1 is negative 8, which is equal to 193. Then after that, we take the negative 8 and the positive 1, we transpose it to the right hand side, because this is a linear equation. And with linear equations, guys, just like we did in grade 8, it's simply transposing the constant terms on one side, and then if we have a coefficient of that particular variable, we divide both sides by that coefficient of that particular variable. So 193 plus 8 minus 1 gives us 200. We then divide both sides by 8 because the coefficient of n is 8, so we divide both sides by 8. 8 divided by 8 gives us n, the variable that's left behind, because it's 1n, and then 200 divided by 8, we get 25. Okay, so our final answer is term 25 is equal to 193. Katie, which grade are you talking about? Because this is grade 12, and algebraic expressions just got done with that grade 11. Okay, you just need to subscribe to my YouTube channel if you want to watch what I've done with the grade 11s. That's if you're talking about grade 11. If you were talking about other grades, grade 9, I'll be doing tomorrow at 7 o'clock. Grade 10, it's 8:30 tomorrow morning. I don't know which grade you are specifically referring to. But like I said, that is it. Grade 8, we're not having any sessions with grade 8 because there's a lack of commitment from grade 8s in the live sessions. That's what I've observed. And I think it's maybe because they are coming from I don't know, maybe primary school, so maybe the thing of live sessions and being there is not really something that they are acclimatized to as of yet. Okay, let's look at this one now. So hopefully we understand how to do it looks easier on TikTok than in class. Yeah, but we need to change that, right? Because it has to look easier for you when you do it more than anything else, and then it has to be easier when you are sitting in an exam and writing it. That's what needs to change, and the only way that will change is we need to stop being spectator onlookers, like in a soccer match between Orlando Pirates and Kaizer Chiefs, simply watching the match and feeling like if I was playing in that particular match, I would do a better job. We need to start being people that are proactive. After we learn something, we go into the textbook, we rummage through all the exercises that we can do, we do all of them. We have someone who we trust, maybe a teacher at school or whatever the case may be. You might have them on WhatsApp, they check your work. You do past papers, you ravage through that, you make sure that that particular topic is sorted. Then that way you'll stop being someone who says it looks easy in certain places, because it will always be easy anywhere and everywhere that you step into. It's very important. This is grade 12. Okay, let's look at this. We can determine the number of terms in a sequence by equating Tn to the last term's value and solving for n. Let's look at this, guys. It says we can determine the number of terms in a sequence. Maybe you are given a sequence and then they ask you how many terms are in this sequence. I mean, if you want to know how many terms there are in a sequence and you are given a list of numbers, right, and you know that that particular sequence is an arithmetic sequence, what this thing is saying here is that we can determine how many terms there are in a sequence by doing what? By simply equating Tn to the what? To the last term's value. And then after that, doing that, solving for n. That way we'll be able to know we'll know the position of that last term, and therefore when we know the position of that last term, it means that that's how many terms we have in that sequence. I hope it makes sense, guys. All right. So I repeat again, we can determine the number of terms in a sequence by equating Tn to what? To the last term's value and solving for n. Right? Yeah. So that's why, for instance, they say Tn is equal to L. This L stands for the last term value. Okay. So if you take Tn and you substitute it by L, then basically you can determine that. Yes, definitely Ganahom. It's going to have to be a finite sequence. I mean, a finite sequence meaning that it has an end. We're not talking about an infinite sequence here. We're talking about a finite sequence, definitely. Okay. I thought that would just follow as logic, but yeah, we can spell it out. It has to be finite, okay? Meaning there has to be a beginning and there has to be an end to that sequence, It has to resemble there being a specific number of terms and not ongoing forever. So a plus n minus 1d, which represents Tn, is equated to L meaning the last term value. So let's look at a sequence. It says here, find the number of terms in the arithmetic sequence of -2, -6, -10, all the way to -150. Yes, a linear pattern is arithmetic, guys. All right, it's just that in grade 10 and in grade 9, you guys did linear patterns, and there was sort of like the specific call to use Tn is equal to Bn plus C as your general. But now, when you're in grade 12, we basically attach the concept of arithmetic sequence to linear. We then also talk about the general term Tn is equal to a plus n minus 1, the whole thing d, and then we work from that premise. Okay, but linear and arithmetic sequence are pretty much the same pattern conceptually. Okay. When there's a second difference, then it's no longer an arithmetic sequence. But if there's a second difference and that second difference is constant, then we are talking about a quadratic sequence. Okay. We've looked at that. That was our first topic. But you can go to my YouTube channel and check it out if you want to actually have a development of your conceptual understanding about that. So find the number of terms in the arithmetic sequence. We have -2, -6, -10, and the last term value is -150. So let's check this out. A, the first term is -2. D is term 2 minus term 1, confirmed by term 3 minus term 2. Okay. Does that make sense? So A is equal to -2. D is equal to term 2 minus term 1, confirmed by term 3 minus term 2. So -6 in this case, minus, because of the sign of the expression in the formula, minus -2. -6 minus -2. That will give us -6 plus 2, which is equal to -4. So that's why we have -6 plus 2, which is equal to -4. That is our what? Constant difference. So A is equal to -2 and D is equal to -4. Okay, then from there, because we want to find the number of terms in the arithmetic sequence, we want to equate Tn with the last term. What is the last term in this sequence? It's -150. So we're going to say Tn is equal to L, then write down the general expression of Tn, which is A plus brackets n minus 1 brackets D. Remember, the D can be written before the n minus 1 because multiplication is commutative. The order doesn't really matter, just as long as we remember that a monomial multiplied by a binomial means we distribute by multiplication the monomial into the binomial. -4 times n, -4n. Positive and negative gives us a negative. So -4 times -1 is +4. Then we add like terms. Okay, this -2 and +4 we can transpose to the other side. 4 becomes negative. -2 becomes +2. We add, we get -152. -4n isolated. Yes, I do. I post them onto the YouTube channel. -4n isolated, we divide both sides by the what? By the coefficient of n, which is -4. Why do we divide by -4? It's because the -4 and the n have a relationship of multiplication. So to get rid of this -4, we need to apply the inverse operation, which is division by the same number. So we get n is equal to what's -152. What we do on the left, we do on the right. Divided by -4 gives us n is equal to 38. That means the last term in this sequence occupies the 38th position. If the last term occupies the 38th position, it means how many terms do we have in the sequence? If the last term is the 38th is in the 38th position, it means there are 38 terms in the sequence. Because the question was saying find the number of terms in the arithmetic sequence. So we conclude and we say there are 38 terms in the arithmetic sequence. Yes. So Kaylee, I hope you were answered. Bree says, what time do you go live and do you do random topics? No, Bree, I don't do random topics. Going according to the ATP per grade. How far I am now with grade 12 is I'm currently doing arithmetic sequence, which will be followed by geometric. I started with quadratic. That's done and dusted. And all the videos that I do, I post onto my YouTube channel, which you can find the link of it in my bio. You can check out what I've done in the live sessions previously. Okay, so I follow the ATP. Very key. Okay, then we can solve for, so I hope that's clear how we got the number of terms in the sequence. Hopefully that is clear, guys. Equating the last term with Tn, and then substituting our A and our D. Algebra, people. What I love about these first few topics of sequence and series, I don't only love the concept that is covered, which is basic. And I know some of you feel like, this is too basic. One of the things that I really love about this topic as well is that it makes you renew your understanding of basic concepts of algebra, like solving for unknowns, adding of like terms, application of additive and multiplicative inverse. These are basic things that you need to know. As a grade 11 learner who's going to grade 12, you need to be mastering how to do these things. You know, this thing of adding, for instance, -6 minus -2, the fact that a negative times a negative is positive, those things are things that you get an opportunity to revise through this topic. So don't ever undervalue this topic and simply feel like, can't wait, we must do geometry. Some of you are so in a hurry to do other topics, but you have not mastered the basics of the topics that you have at hand. So let's focus on that, okay? I know, I've said it before, and I'll say it again, and I'll say it again. Because I'm passionate about that, and it just makes me sad sometimes that people just want to rush, get over this and do something else, okay? Unfortunately, if you are here again, it's your fault. You could go to Kevin's, Kevin Maths and Science, and you can get ahead of the game if you want. Brilliant resource, by the way. Kevin Maths and Science is the best. Or who's that guy? Lungis Nkosi. Great guy, great people, those ones. You can follow through. Their sessions are powerful people there. Okay. So let's go here. We can solve for unknowns in an arithmetic sequence. We can solve for unknowns in an arithmetic sequence by remembering that T2 minus T1 is equal to T3 minus T2. I repeat, we can solve for unknowns in an arithmetic sequence by remembering that T2 minus T1 is equal to T3 minus T2. So because the first difference is constant, that's why we can have the formulation of these differences, the first differences being equated because they are constant. Remember, if it was a quadratic sequence, it wouldn't be the first difference that are constant. It would be the second differences that are constant. You equate those. So this is important because conceptually, you guys, whenever you are doing sequence and series, you need to always look at the question. What is stated in the question? Remember, for now we are doing these individually, doing quadratic alone, doing arithmetic alone, geometric alone. Then we do arithmetic series and geometric series alone. Then all of a sudden, and then we do word problem types alone. Then all of a sudden, when we consolidate the topic, we start looking at mixed masala type problems. Mixed masala type problems. Then there you need to actually pay attention to the wording and check what type of sequence are they talking about here, so that you can actually incorporate, the right approach. So look at this. We have x minus 1, 2x plus 2, so this is term 1, then 2x plus 1, which is term 2, 5x minus 1, which is term 3, are the first 3 terms of an arithmetic sequence. And we can see that expression of term 1, the expression of term 2, the expression of term 3 in terms of x. Now they are saying determine the value of x. So what do? We apply exactly what we've just been exposed to. They said that the constant difference are constant. The first difference, are constant. And please, people, don't ever say T1 minus T2. Let's make sure we are always saying the later term minus the previous term. The later term minus the previous term for consistency. So T2 minus T1 means T2 is 2x plus 1. It's a binomial. So we need to be careful. Minus. When there's a minus sign and a binomial follows, please put the blooming brackets around the binomial. Do not put the brackets around the blooming binomial. The binomial needs to have brackets. Okay, the binomial needs to have brackets. Wilmore, there's no ways that I'm having network problems because I can see my green dot is green, which means my network is 100%, it's good connection. So Wilmore, I think you are having problems with network. It's not me, it's you. You know what people usually say, it's not me, it's you. No, it's not me, it's you. I think it's you. It has to be you. Unless there's someone else who can confirm what Wilmore is saying. They're also saying that I'm having problems with network. Someone else can confirm it? Are you guys experiencing difficulties? Didi. Thank you, Kanawama. I really appreciate it. You have network problems. No network problems. Okay, so that means different people are experiencing network problems in their various situations. King Mac is saying, yes, I can confirm it. No, we are perfectly fine. It is network. It's only them. So I see. So it must be, guys. I think you guys are having problems. Because I can see the green for me. Things are good. Very good. So like I said, we put a bracket around the binomial after the negative sign. Please, people. Why? Because this negative sign after it has been placed needs to be distributed to both terms so that we get this negative x. Negative times x gives us negative x, then a negative times a negative 1 gives us a positive 1. Had we not put the brackets, I can rest assure you and promise you would have said negative x and then you say minus 1, and then that would have basically led us to a different answer and a wrong answer at that. So we need to make sure that our minus sign is followed by a bracket where there's a binomial, meaning 2 terms. Then what about term 3 minus term 2? Again, term 3 is 5x minus 1. Minus before the minus sign, then after we put the brackets, please, and then make sure that it's there so that the minus can be distributed into the bracket. What's minus 2 times x? Minus 2x. What's minus times positive 1? Negative 1. Then of course, what do we do from here? We transpose the like terms. 2x minus the x. Then 5x crosses over, it becomes negative 5x. Please, people, when terms cross over, we know the sign changes. Then minus 2x, when it crosses over, it becomes positive 2x. Is equal to, the negative 1's already there, that's fine. This negative 1 is also there, that's also fine. This positive 1 crosses over, it becomes negative 1. This positive 1 as well crosses over, becomes negative 1. What's minus 1, minus 1, minus 1, minus 1? Negative 4. Then this side, 2x minus x minus 5x plus 2x gives us negative 2x. Then you can see most from here, people, we just divide both sides by the coefficient of x, which is negative 2. What we do on the left, we do on the right. And then x is equal to, amazingly, positive 2. Gaitola ntwe. Ha ha ha, gaitola ntwe. Ha ha ha, gaitola ntwe. Gaitola ntwe. Yeah. Okay. Then we have the value of x. So if we have the value of x, people, it's negative 2. Okay, what did the question say? Determine the value of x. And then the next question says, determine Tn. We need to determine Tn for this term. We got x is 2. So what we can do is we can take the 2 and substitute in the individual terms. Take the 2, we substitute here. What's 2 minus 1? Gives us 1. 2 minus 1 is 1. Take the x, which is 2, substitute here. Remember, when we substitute, we put in brackets, especially when there's the 2 next to a variable. Okay? So 2 times 2. What's 2 times 2? It's 4. I'm glad, Womo. I'm glad, guys. If there's moments of like realization that, oh, now I understand it. Hallelujah, I say. Hallelujah. Amen. 2 times 2, that's 4. 4 plus 1 is 5. There it is, guys. 2 times 2 is 4 plus 1 is 5. So our first term is 1. Our second term is 5. Let's take this 2 again. And where do we substitute it? We substitute it here. 5 times, in brackets 2. 5 times 2 is 10. 10 minus 1 is 9. 5 times 2 is 10. Minus 1 is 9. So our terms are 1, 5, and 9. When we check these terms, do they actually produce a arithmetic sequence? 5 minus 1 is 4. 9 minus 5 is 4. I think we are on. We are spot on, guys. We are spot on, guys. We are spot on, guys. We are spot on. Yeah, yeah, yeah. We are spot on. So A is equal to 1. D is equal to 5 minus 1 is 4. 9 minus 5 is also 4. We've got A is equal to 1. We've got D is equal to 4. Guys, we can now find Tn. Tn is equal to A plus n minus 1 brackets D. Tn is equal to A was equal to 1 plus D. We write D obviously before the bracket so that we can distribute the 4. 4 times n, 4n. 4 times negative 1, negative 4. We add the like terms. 4n, 1 minus 4 gives us negative 3.